System of linear equations. So we have two equations here. Both of them are linear functions, which you learned about in Algebra 1. They're both in the form y equals mx plus b. So our goal here is to graph both of these linear functions on the same grid. And what we're looking for is, we know that this linear function right here has infinitely many solutions. And when we graph it, we can see the solutions. And this function has also infinitely many solutions. And when we graph it, we see those solutions. We're looking for where they cross each other, where they crisscross, and that's a shared solution that they both have. And that's called solving a system of linear equations using graphing method. So here we go. Let's graph this right here. So this is a linear function. We know that this is the y-intercept, so we start at 2 right here. We see that the slope is -3. So we go 1, 2, 3 over 1. It's a negative slope, so it's going downhill. And this is a graph of all the solutions. Even though I only plotted 2 of them, the line is showing all the solutions to this linear function. And there are infinitely many. That's why this goes on and on. This function is also a linear function. It starts at -5. 1, 2, 3, 4, 5. That's a y-intercept. This is my y-axis. As my y-intercept is -5, my slope is 4, so I go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I connect the dots. This green line shows me all the solutions to this linear function. So the purple line shows me that there are infinitely many solutions to this function. The green line shows me that there are infinitely many solutions to this function. Where they cross each other, which is right here at the point 1, -1, this shows me that this particular solution right here works for both of these equations. So even though they both have infinitely many solutions, there's only one solution that they share, that they have in common. So this solution, when you plug it in, works for both equations. So let's just plug it in and see. We're saying 1 for x, -1 for y. So if this x is 1 times -3 is -3 plus 2 is -1, which is what I get here for the y value. Same thing here. If x is 1, 1 times 4 is 4, minus 5 is -1. And so this solution works for both of them. Okay? So there are infinitely many solutions to both, but there's only one solution that they share, and that's what we're looking for. So the answer to this system of linear equations is 1, -1. And on the graph, it's where they crisscross. In another video after this, we're going to see other methods to solve a system without looking at a graph, and it's called substitution and elimination, but we'll look at that later. So let's look at one more example. Notice that in this example, they were both in function form or slope-intercept form, y equals mx plus b. In the next example, only one of them is in slope-intercept form. So we'll just have to rearrange the other one. So we see here, this one's easy to graph. It starts at -2. That's my y-intercept. The slope is 2/3, so up 1, 1, 2 over 1, 2, 3. So it looks like this. That's the graph of this function, all the solutions. This one is not in the form y equals mx plus b, but it's easy enough to just move this 2x, subtract 2x from both sides. Notice over here these cancel, because we get 0. You now have y equals, you cannot combine these, they're not like terms, so you have -2x plus 6. Now it's in slope-intercept form. My intercept is 6. 1, 2, 3, 4, 5, 6. My slope is -2, so down 2 over 1, down 2 over 1, down 2 over 1, and there it is. There's the intersecting point. So this point right here, which is 3, 0, is the solution to the system, meaning that that solution will work for both equations. If I plug in 3 here, the 3's will cancel, and I'll get 2 minus 2 is 0. So it works, 3, 0. If I plug in 3 here, I'll get -2 times 3, which is -6, plus 6 is 0. So -3, 0 is a solution to both systems at the same time. So that's called solving a system of equations or a system of linear functions and looking for the common solution.